We're going to continue on our journey into geometry proofs. We're going to be on page 29 today. And geometry proofs, we talked about the algebra proofs the other day. Okay, if you're still struggling with those, go back. Make sure you have your valid list of reasons here as you go through it so that you can help identify some of those reasons. As we move into geometry proofs, things will become a little bit more difficult. And the best way to get better at these are to just practice them, read over them. Like I said the other day, there's not one correct way to do the proof. Okay. As long as your statement is valid, and your reason is a valid reason off of this sheet, you're fine. Okay. Order does matter on them, so make sure you're also going in the right order. Okay, as we move into geometry proofs, there are a lot of things on this page that we have already talked about, but haven't necessarily wrote it down on this sheet. Okay, and a lot of those are definitions. So let's just talk through some of these and we will write down kind of what they are. Okay, so definition of angle bisector. Remember, a bisector splits something in half. In this case, we're splitting an angle in half. So divides angle into two congruent. It divides an angle into two congruent angles. Definition of segment bisector. Very similar. It's something that divides a segment into two congruent parts. So divides segment into two congruent parts. Okay, so if they say that you have an angle bisector, you should be thinking about using the definition of angle bisector somehow. Definition of midpoint. Divides segment into two congruent parts. Okay. A midpoint is a segment bisector. They're the same, they just have a little bit different word. Okay, definition of right angle equals 90 degrees. Definition of perpendicular, cross at 90 degrees. Definition of congruent. Okay, this one's a little bit tricky. Definition of congruent means has equal measure. When I use definition of congruent, I'm going from congruent symbol to equal sign or equal sign to congruent symbol. Okay, so when I use that, I'm transitioning from an equal or congruent, one or the other. Definition of complementary angles. Sum to 90 degrees. Definition of supplementary angles. Sum to 180 degrees. And then we'll leave, definition of adjacent angles. Angles that share side. Definition of parallel lines, same distance apart. Okay, so these are some definitions that we've already gone over in that unit 1. Okay, and we're going to look at using some of these as we move into geometry proofs. Now, these first proofs that we're going to do are going to solely be based around segments and angles. Okay, so we're going to start off kind of easy here with segments and angles. So again, we're on page 29 of our notebook, and we're going to start here with let's turn this. So angle and segment proofs. Okay, and we're going to start here with kind of remembering. I do believe it's on here somewhere. Oh, right here. Okay, so we have the angle addition postulate and segment addition postulate. Okay, and we've talked about those. The angle addition postulate is adding angles together to get a larger angle. And segment addition postulate is adding segments together to get a larger segment. Okay, so again, looking back at some things that we have done, we can add angles together and we can add segments together. And we'll look at that with some of our algebra as well. Okay, so we're kind of combining some Unit 1 stuff with our algebra proofs, moving into geometry proofs. Okay, so having this thing filled out and handy will be very helpful. Okay, so let's start here with a picture. And the picture is going to look like this. We have a 1, 2, 3. We have some letters, B, A, C, D, E. Okay, and this is what it says. Given, now let me just write it down here. Given that the measure of angle 1 equals the measure of angle 3, and they note that here, that those two have the same measure. We want to prove that the measure of angle DBA equals the measure of angle EBC. Now, having the diagram here, the picture, the figure, is going to be beneficial for us. Okay, we don't have to draw that out. Most proofs that I have you do, I will not have you do a full 2-column proof. Okay, most of the proofs that I have you do will look kind of similar to what you see on your homework. There will be blank holes in the proof, and you're going to have to kind of fill in the blanks. Okay, so on this first proof here, we will start with our statements and our reasons. And again, the first statement is always what you're given. Okay, they are giving me that the measure of angle 1. So the measure of angle 1 equals the measure of angle 2. That is given. I'm sorry, that's a 3. The measure of angle 3. Okay, they're giving me that. So 1 and 3 are the same. Now, if we look here at what we're trying to prove that angle DBA, so this big angle right here, is congruent to EBC, this big angle over here. So this angle, you can kind of draw, I want to know that this angle here is the same as this angle here. Okay, well, if we think about this angle, DBA, how can I create that angle right there? Well, if I add angle 2 and 3 together, I get that whole angle. So we're going to say that the measure of angle DBA equals the measure of angle 3 plus the measure of angle 2. Okay. We also know here that I can take angle 1 and angle 2 and get EBC, which is what I want down here, EBC. So the measure of angle EBC equals the measure of angle 1 plus the measure of angle 2. And I write those in the same spot because they have the same reason. Think about what we're doing here. We're taking two smaller angles, adding them to get a larger one. This is the angle addition postulate. Okay, that angle addition postulate. Now, if we take one of these, it doesn't matter which one, remember that the measure of angle 1 equals the measure of angle 3. So right here, I could take this line right here, and I'm going to bring it down here. But instead of writing the measure of angle 3, I'm going to put in the measure of angle 1. So we're going to say the measure of angle DBA equals the measure of angle 1 now plus the measure of angle 2. And what I did there is instead of writing the measure of angle 3, I wrote the measure of angle 1. So I did the substitution property. Okay. Now here we can see that the measure of angle EBA also equals the measure of angle 1 plus the measure of angle 2. And I have the measure of angle 1 and 2 equal the measure of angle DBA. So I can link those together and say that the measure of angle DBA equals the measure of angle EBC, and that is the transitive property. Because I went from DBA to 1 and 2, 1 and 2 EBC. Okay, so I linked those two together. Now this is what I wanted to prove over here. So now that I've said that, I'm done. Okay, there's no more to do on that proof. We are finished. Okay, so we're looking at adding segments or angles together in these proofs. Okay, it's about understanding these properties here on this sheet and how to use them. Okay, let's look at another one. Okay. So let's say we're given that B is between A and C. AB equals 9. BC equals 7. Prove AC equals 16. Now here they don't give us a diagram. That doesn't mean we can't write one, but they just didn't give us one right away. So statements, reasons, first reason is always given, and we're just going to copy down what they gave us. So B is between A and C. AB is 9. BC is 7. Okay, now going along with that, I can start creating a diagram, okay, or a picture. So I know that B is between A and C. So if I start drawing something out, here's A, here's C, and B is between them. Something like that. I know that AB is 9 and BC is 7. And I'm trying to prove that AC is 16. Okay, well, I know that AB plus BC equals AC. So AB plus BC equals AC. Now again, what did I do there? Well, I took this little segment plus this little segment to equal the whole thing. That is segment addition. Well, I know that AB is 9. So instead of writing AB, I'm going to write 9 plus BC is 7. So I did two things there. I don't know what AC is. I did two things there, but it's got the same reason. And what we did there is we just substituted values. So that's substitution. Okay, well, here I can take 9 plus 7, and 9 plus 7 is 16 equals AC. Whoop, not G, AC. And what did I do there? Well, I added on the same side. According to my sheet here, when I add on the same side, that is the addition property. Okay. Well, here I have 16 equals AC. It wanted me to prove that AC was 16. We could stop here, but some people or some authors or some texts want you to match identically what is here. Okay, well, I don't quite have that here, but I could write AC equals 16 and just reverse the order. If we look here, when I reverse the order, that's just the symmetric property. So symmetric property. And in fact, this would be the symmetric property of equality because we're dealing with equal signs. If that was a congruent sign, we would say symmetric property of congruence. Okay. All right, and there's another proof. This was a segment proof with segment addition here. Okay, I want to do one more. Let's maybe do a little bit harder here. And let's say, given angle 1 is supplementary to angle 3. Angle 2 is supplementary to angle 3. And I want to prove that angle 1 is congruent to angle 2. And they give me a little diagram here. Okay, they say this is angle 1. This is angle 3. And they say over here is angle 2. So nothing super helpful here on this diagram, but they do give me something. Okay, so we have statements and reasons, and we may need the whole rest of the page here. Okay, so the first statement is what they provide me. So angle 1 is supplementary to angle 3. Angle 2 is supplementary to angle 3. And that is all given. Okay, so let's think about what does it mean to be supplementary? Well, according to our sheet here, supplementary angles sum to 180. So that's what I'm going to do. Okay, I'm going to take the measure of angle 1 plus the measure of angle 3 equals 180, but also 2 and 3. So the measure of angle 2 plus the measure of angle 3 equal 180. Now, what did I use there? Okay, because this isn't, even though we're adding angles together, it's not angle addition. Okay, it's not this angle addition. I used the fact that I knew what supplementary angles were to make these sentences. So that is definition of supplementary angles. So definition of supplementary, and we can abbreviate angles. So definition of supplement angles. Now, here we have that the measure of angle 1 plus the measure of angle 3 equals 180. And we have the measure of angle 2 plus the measure of angle 3 equals 180. So we have these two things equaling 180. Well, instead of writing 180, I can set them equal to each other. So the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. Now there's two kind of reasons you could put here. Number one, you could put the transitive property because we're kind of linking some things together. But kind of the more appropriate one would be the substitution property because we substituted this value in for 180 there. So we're going to write substitution. If you wrote transitive property there, I'm not going to count you wrong because that could be the transitive property as well. Well, transitive property will usually show up at the very end. Okay, well, looking at this, it looks like I got the measure of angle 3 on both sides. So I could subtract the measure of angle 3 from the left and the right, leaving me with the measure of angle 1 equals the measure of angle 2. Well, when I subtract the same thing from the left and the right, that is the subtraction property of equality. Now, if we look here, we don't quite have what we need to prove. Okay, here I have an equal sign, here I have congruent. Well, if the measurements of these two angles are equal, then they are congruent. We talked about that at the beginning. Definition of congruent: has equal measure. Okay, these two things have the same measurement, so angle 1 is congruent to angle 2, and that is the definition of congruent. Remember, I said anytime you want to transition from an equal sign to a congruent sign, or from congruent to equal, you're using the definition of congruent. So when you need to switch that sign, you're going to use definition of congruent. Okay, now I know that these are going to be tricky. Okay, that's why I'm not making you do full-on proofs. Okay, you may have to figure out, okay, what is this step? What is this step? What is this step from a word bank? So I encourage you to get some practice on the big ideas, and I'll also put another website up to where you can go on and kind of click through some proofs and get some practice on these. If you do not have this filled out, it's going to be tough. Okay, anything that I have written on here, you can write on yours. So you might as well go ahead and get that going from here on out. If you have questions, feel free to reach out.